Hi, I'm Pete from Project Heaven. In this series of videos we're going to show you some of the measurements that we carry out when we're rebuilding an engine. In this first video we're going to show you how we check if a crank is running true. We put a dial test indicator gauge on each journal and check for the maximum run out. Mark that on the crank and record it on paper exactly how many thou that is. What we're looking for is the same amount of deflection on each bearing journal in the same direction. If that's the case, then we know that the crank is running true, but if you have varying amounts of deflection on each journal, then it possibly isn't, and the crank could be bent. If the crank does turn out to be bent, then the first thing we should do is check it on our crack tester to make sure it's not cracked. If it's not excessively bent, or if it's been ground incorrectly the first time round, perhaps if it's still within tolerance, we could grind it again to get it running true. This crank turned out to be good. The deflection was in the same direction on each journal and pretty much the same amount. You might be wondering why there is any deflection. That might be because it's being held between centres, and where it's being held on the crank could be damaged, causing it to be slightly off. As long as the deflection is the same and always in the same direction, then the crank itself is running true. Next we'll show you how to measure the crank journal diameters accurately with micrometer screw gauges. Here we're using my set of old imperial gauges, but they're very accurate. Here I'm just checking that the micrometer screw gauge is accurate with the calibration bar. I'll start off by measuring the main bearing journals. You measure 0 degrees and then at 90 degrees and record the readings. Then we'll measure the big end journals, the same thing, at 90 degrees and at 0 degrees. Now we're doing some bore measurements. We'll start off by measuring for ovality with a special DTI gauge that checks the bore's ovality. We'll start off at the top and then work our way down to the middle and the bottom, and we'll do it 0 degrees and 90 degrees and take readings of all this. If it turns out that the bore is excessively worn, then it will possibly need a rebore. If it's not excessively worn, it's still within tolerance, then perhaps it will just get away with a hone. Now I'm going to measure the actual bore diameter with a special kind of micrometer screw gauge. With this information we'll know if the bore is standard or if it's been bored out before, and also if there'll be enough meat left in it to bore it out a final time. Now we're going to plastigauge the crank to check for bearing clearances. Then we break off little pieces of the plastigauge material and lay them on the crank journals. We'll then reinstall the main bearing caps. And torque them down to 100 inch-pounds on this XK140 engine. Once the main bearing caps have been torqued up correctly, we'll then undo them, remove them, and then use the plastigauge reference card to check to see how much the plastigauge is squashed down by. The wider it is, the closer the tolerance, and the thinner it is, the larger the tolerance. You'll need to check the clearance with the manual. If the clearance is too tight, then the crank may need to be ground again. If the clearance is too big, then the crank may need to be ground to the next oversize and use oversized bearings. Thanks for watching today's video. If you need any help or advice with rebuilding your engine, don't hesitate to get in contact with us.